I think when most people think of STEM, they think of science, technology, math, engineering, and the way that those subjects fit together. We think about that in schools as a way for students to make some connections between the subject areas and not have them be standalone classes. We continue to move a little bit deeper, I think, than some districts go with STEM, in that our teachers really collaborate together to create challenges that students can solve based on that integration.
Science teachers and math teachers collaborate and they look at the standards and they look where those math standards and where the science standards fit and how they can use them together.
Learning is really an integrative process with a lot of different things, subject, content areas, standards, fitting together. I mean, that's really more real life. We don't really walk around outside in compartments of, I'm going to do math right now, I'm going to do science right now, or I'm just going to do technology, that it really all fits together.
We're very intentional in the way that we look for connections between math and science. We look for connections that are not only naturally occurring in the curriculum, but we also look for intentional hits, places that we can maybe move the curriculum around from the standard scope and sequence and really find places where overlaps occur. We do that so that students can actually apply what they're learning from both their math and their science classes and put those things together to apply that knowledge in a new situation.
And then we plan scaffolding activities to build up the content knowledge for them to be able to solve and go through the engineering design process steps to be able to solve a challenge that we have for them that is based in a real life or maybe even a local community-based problem.
What it looks like in the classroom is a lot of student collaboration, a lot of experiments, a lot of activities. It's not quiet. There's a lot of math in the science class and a lot of science in the math class. And then through all of that, there's pieces of technology brought in as well. But it's all based on students thinking and solving and using what they've learned to solve some type of situation.
One of the unique aspects of the engineering design process is just the idea of struggling. When students come up with a plan and the prototype does not materialize into producing the results they expect, then there is an element of perseverance that they have to find and maintain, and being able to think critically and how can they improve their solution and their solution path and what went wrong with why it didn't work.
Students learn when they have to think through something. So if they are told that answers are right, if they are told that answers are wrong, without ever having to go through any of that and figure it out on their own, they're not going to truly learn it. So if there's a little bit of struggle when they're trying to solve this and they realize that that's okay, then they're going to be more apt to explore and not be so confined to what the teacher says, but they will be more confident to learn and explore different avenues than just what the book said.
The struggle also produces a longer, deeper learning that takes place than if it was just an easy find or an easy thing to learn for them. So I think overall you have a greater student achievement as a result and byproduct of that struggle.
They're working to create new knowledge that isn't just what came out of the book. It's not just what the teacher told them. It's information that the students are getting from working from each other. So those 21st century skills, things like integration of knowledge and use of technology and all of the things that are going to make students successful as they go from grade to grade and then they leave CMCSS and go on to college or go on to career, they're going to be better prepared for those experiences and those challenges because they've been able to not only work on a Scantron, but work on actual problem-solving skills in a new way that has integrated math and science and technology and English and social studies and some of those other skills that are necessary for success in the future.